Yeah, it's always good to be down in Limerick, where I suppose KOSMOS has our Irish headquarters. I'm based in Dublin, but what amazed me about Limerick is just the ambition that Limerick has and the potential it has. And I think Darren's presentation just shows there that anything is possible. And I think 2030 is used in their name, but I think for all of us, we have to start projecting out what 2030 looks like. How is it going to affect our day-to-day work? How is it going to affect real estate and construction? And what I want to talk about is just the data element of that. How do we, synchronize our data and collate our data so that we know where we're going? So as it says, we are KOSMOS, and I'm joined by my colleague and the founder here, Ross Griffin. And KOSMOS, I suppose, are a digital quantity surveyor. And we work predominantly in the Nordics, but we also have global projects. And they're run from offices in Copenhagen, here in Limerick, and in Dublin as well. So I suppose there's a lot of transition going on, not just in digital, in climate, but I think right across real estate. It's in flux, and I suppose one of the most important dynamics here is that we need the numbers. We need to know where we're starting and where we're going. And I suppose quantity surveying is all about the quantum, the numbers, the costs. But it goes beyond that. And I think we also need better control over numbers so that we can inform and advise project funders. We can also start to understand the users of the building. So we start to think about these buildings in more of a life cycle terminology. So it's not, a design team designs it, hands it over to a contractor. The contractor then builds it, and everyone buggers off. The life cycle approach means that from the very concept of that building, you have to be thinking about not just how it's operated and managed, but how it's deconstructed. So it's a completely new mindset, this life cycle approach rather than a project approach. So our way of getting into this is to look at sustainability through the lens of value, because as you know, sometimes sustainability can be a little bit of greenwashing. It can be a little bit of, let's make it slightly better than it would otherwise be. But really, to affect change in sustainability, you need to have a budget for it. So the common language for sustainability really is cost. And when you have a common language like that, you can have full integration, you can have collaboration, you can have everyone working towards common targets and common budgets. So that integrated collaborative approach means that, you can control, you can set targets and work towards those targets. And if those targets then are linked to a budget, you can ensure that they're implemented correctly and followed up on. So KOSMOS have a team of about 25 people, with about 19 of those based in Denmark. In our sustainability team, we have M&E QSs, we have carbon specialists, BREEAM, lead DNGB sustainability specialists as well. But we're within within a cost team. So in KOSMOS, we don't have separate departments for commercial management, for cost, for carbon. These are all part of the same organization and part of the same process. So at each step in the process, we integrate cost, we integrate carbon, we integrate value management. So I suppose our approach would be a kind of a science-based targeted approach to sustainability. It's very quantitative, and we're trying to add value to cost commercial through the lens of carbon and delivered in a digital format. So I suppose digital is I suppose the means to achieve the client's ambition. So to do that, we need to control the figures, the budget figures, the carbon figures. And to us, carbon and cost are intrinsically linked. You can't impact one without impacting the other. So I suppose to add value to sustainability, we would set a cost budget, set a carbon budget, and use that then to achieve those targets through collaboration. So I suppose the first thing is looking at, I suppose, carbon literacy, understanding the impact of carbon in buildings. And then how do we actually count that? How do we put a target on it? How do we set figures for what good looks like and what better looks like? And then what's important is, at the moment, if somebody sets a target for sustainability, it's really dependent on what country they're based in, what standard they're using, and I suppose what the organization's ambitions are. So we're trying to standardize that and say, no matter what country you're in, no matter what type of building you build, you can set a target for your projects or for your pipeline. And then I think what's important is that we don't do this in a silo. We look at best case examples from London or from Denmark or from the US and see what works there. So I suppose what's driving all this? What's driving this, the increasing emphasis on not just sustainability, but on decarbonisation? And I suppose at the moment, we have a large kind of deficit in housing that we're trying to meet. And at the same time, we know that construction is quite dirty. It's responsible for about 36% of global emissions, and about 11% of that is just down to the supply chain, to the materials we use. And, despite the best efforts of projects to, reduce the impact of those big high volume materials like steel and concrete through recycled content and reducing the thickness of slabs, it's still very difficult to reduce your overall footprint if you're building more volume and at the same time trying to reduce your footprint. So the challenge is quite massive. So, in Ireland, if we're trying to build, 100,000 houses a year, how do we do that without increasing our carbon footprint? So that's a challenge as we head, beyond 2030. So we need to kind of have an understanding, have a more intuitive understanding of the impact of carbon and where the carbon kind of hides out within our construction projects and our retrofit projects. So the way we do this is through whole building life cycle assessment. So that's that life cycle word again, we're taking a whole of life approach to design, procurement, management, maintenance, operations, and disassembly. It becomes the whole life of that project. And so we carry out an assessment, and that assessment looks at those impacts from the construction process, from the management of the building process that affect the environment, that add carbon to the environment. So we look at break that down to the individual products and the processes from that. And then we try and measure that against climate impacts like carbon, like methane, like water use. So why is it responsible? Why is it important? And buildings are a big part of our overall global carbon footprint. And we need to know where to target our energies. Should we target in transport? Should we target it in energy? But buildings, because they're responsible for so much of our climate impact, they're kind of an easy target. So it's easy to set policies to target real estate and construction. And so we use life cycle assessment calculation to tell us where we are right now with our projects and where we're going, and to set decarbonisation targets that become more stringent every year towards 2040 and 2050. So how do we define this life cycle approach to carbon? And what we say is, look, we have some of the carbon that's related to the use of a building, and that's kind of the 50% there that's black. The use of the building being, running the chillers and heating hot water, etc., running the fans. But we also have to consider the embodied carbon. So the upfront embodied carbon, which is the carbon that's in the structure and the materials, and then the downstream, which is in the maintenance and replacement. And I suppose historically, operational carbon was kind of 70–80% of the equation. But because our buildings are now designed to NZEB or nearly zero energy buildings, that equation has tilted. And as we go towards zero emissions buildings, that'll start to change, where the operational energy will become much smaller. As the grid decarbonizes, the carbon in that operational energy will become smaller, and the embodied carbon will become a bigger part of the whole story. So, it's becoming a higher and a higher priority on the agenda of sustainability. But it also is an important indicator for a lot of the new disclosure regulations that are coming in. So organizations have started to disclose under the EU taxonomy and under the SFRD for their green funding. But next year, other organizations are going to have to start reporting under the CSRD. And part of the CSRD is you have to plot your pathway against Paris 1.5 degree decarbonization targets. So your operational carbon, and if you're an investment company investing in real estate, you have to show your carbon targets, your carbon footprint for each year against those rapidly declining carbon ceilings. So we break down the building into its different components and the different stages of the life cycle, looking right up the supply chain to the raw materials. Where does the steel come from? Is it electric arc furnace from Port Talbot, or is it coal-fired from Turkey? We look at the construction, operations, etc. So we need a lot of data to understand where the material is being produced. We need its environmental product data sheets, and we need the quantum for that. And we have a number of boxes to fill, and these boxes would be kind of the upstream products, the use of the building and the replacement and refurbishment, the deconstruction of that building at the end of life. And then we can also start to look at, do the materials have a life beyond the building? So that'd be looking at things like mass timber, looking at steel, what happens afterwards with that. But like anything with data, there's challenges within that. So when we look at a building, say a school, predominantly the structure and the walls of that are going to take up a large volume. The facade, like the brick cladding, is another part of the volume. And I think it was Bannister Fletcher who said, "How heavy is your building, Mr. Foster?" And that, generally we can equate heavy materials with carbon intensive materials. So we can see like that, the majority of the carbon impact in this building is in the heavy components of structure, cladding, roofing. And so we can focus on those. The Pareto rule is that 80% of the work is in 80% of the materials for us. That's not exactly Pareto, but yeah. So accuracy is important in carbon because it's a bit of a wild west at the moment. Two assessors could do a carbon assessment and come up with completely different results because they're defining it separately. They're using different boundaries, different methodologies. So consistency and accuracy is kind of the order of the day at the moment. So we're trying to make sure that everyone is using the same calculation, and the Irish Green Building Council are working at that, but also consistency, that we know if we measure one building against another, that they can be compared. And in terms of standardization then, in that data, we've been through this process with BIM before, but BIM is quite useful to streamline the process of taking off quantities. So for instance, if you're taking off quantities for cost, it's the same volumetrics that you're going to use for carbon. So instead of measuring twice, you just need to measure once. In terms of identifying hotspots, having a model where you can segregate it by materials is quite useful. And BIM will have more of an impact. I'm looking forward to seeing Simon's presentation on this later. So in terms of standards, there's a number of standards for LCA. So in a way, it's similar to the journey we had with BIM. And I suppose using the BIM models, we can start to take off more accurate quantities, but we can also track the building. So if something changes, well, then the volumes change, the budget changes, the carbon changes. So we can track it at each gateway. But what we've learned from international practice is that over 8 years in Denmark, we've learned that you need to have a standardized process that everyone in the design team, everyone on the client team can fit in with. So we kind of, the outputs are only as good as the inputs. But what's important to us is that the metrics that we have are the climate impacts, the cost impacts, but also the data quality scoring is important. So in Denmark, they have an 8-year head start. We're trying to do this in 3 or 4 years. In Denmark, they've done this in 8 years. But looking at Denmark, it will help us short circuit that. So they wrote life cycle assessment into their building regulations as a voluntary guideline back in 2014, and they built an assessment tool, and then they published it in the regulations and started to test out what good might look like and look for data. And they looked for 80 buildings first of all, and they then looked at 200 buildings to say, what should the mandatory standards be? And in January this year, the mandatory standards came in. And now the designers are coming back saying they're not ambitious enough. They really don't meet our national targets. And so when we do an assessment, we end up with a matrix like this. And often we have figures for the structure, figures for mechanical and electrical systems, and figures for energy and use. But you can get fixated on this number. But the challenge with putting a number on carbon is if the design team are doing that, they don't have the full picture. And by the time the detail gets to the contractor, they have more detail, they have more materials. And what happens is that you get a discrepancy between the design figures and the contractor figures, and someone has to pay for that. So essentially, what we focus on is data quality to be able to say, well, how representative is your carbon model of the construction stage, building? And we would say, well, in terms of structure, your structure is fairly comprehensive, fairly representative. But as you score the data going down towards interior finishes, MEP, external landscape, external civils, you have lower figures. And so your representativity score can be quite low. So to go for tender without having the full picture can be a risk. And what we would do then is, just like in cost, we would add a contingency and say, you need to add a contingency there, because if you are writing performance criteria into your contract, well, then you want to make sure that the main contractor can actually achieve those targets. So I suppose where we come in on public projects especially is to look at, where is the data gaps, where is there uncertainty, and try and either plug those or make sure that there's sufficient budget in place for that. And so there's a kind of a process to do that. And we would say, look, at a very early stage, do some baselining, and then work with the organization or the funders for your goal setting and your data collection strategy. And then start to look at, well, what changes if I apply a life cycle lens? Do I look at materials that have longer service life? Do I look at, air conditioning units that use a different type of HCFC gas? And how do I make sure that I have a maintenance strategy? Do I asset tag with GS1 and SFG20 systems, etc.? How does carbon overlap with the sustainability objectives of BREEAM and LEED and DNGB and levels and all those other good things? And then let's plot this out and look at our net zero roadmap. So we know that the carbon ceiling is reducing all the time as we get towards 2050. Can our building track that? So have we a building that's, say, fully electrified? It can piggyback off the grid. As systems come up for replacement or renewal, they can become more efficient. And the tenants that operate the building, that they can also have a relationship with the landlord that facilitates achieving a zero carbon ambitions. Data quality I've spoken, and that's really where the BIM part of it comes in, that you need to be able to evaluate that. And then optimization. There's an exercise where you look at optioneering, and that's where the BIM model is quite handy, that you can test out scenarios. That's where, you know, using scripts is important as well, that you can test out a range of different scenarios. And at the end then, cost optimization is key, that, you know, you need to deliver value. You can have the greenest building in the world, but, you know, it has to deliver value to its investors and its users. Okay, I'll leave it there.
Thank you very much, Archie.